This presentation is intended to show you the design concepts being considered along Northwest 10th Street at North Pennsylvania Avenue and North Virginia Avenue in Oklahoma City. I'm Erica Myers, and I'm with Lee Engineering, and we were selected by the City of Oklahoma City to provide civil and traffic engineering services for this contract. I'm going to start this presentation by giving you a little background on Lee Engineering. We were founded in 1988 to provide specialized services in the field of traffic engineering. We have offices in several states, including an office right here in Oklahoma City. I would like to introduce you to the project team. Like I mentioned earlier, I'm Erica Myers, the traffic analysis lead. Lee Engineering teamed with half associates on various aspects of this project. The city asked us to evaluate the study area shown here and make recommendations to improve traffic operations and safety. They have a fixed limit construction cost of $1.41 million and wanted us to look at two design concepts, and we are presenting those to you today. The city desires to make improvements in this area for multiple reasons. The existing geometrics are complicated and can be confusing for unfamiliar drivers, especially where the crossover intersection is concerned. The traffic signals are close together, which means that drivers often don't have enough space to make a lane change if they find themselves in the wrong lane. Buses also have difficulty making turns on some of the approaches. The cluster of traffic signals is not typical of other intersections throughout the city and does not meet driver expectations. There is a high volume of pedestrian and bicycle activity in this area, as well as bus stop operations. The crosswalks are worn and difficult to see, some of the intersections are missing wheelchair ramps, and some of the pedestrian push buttons are no longer working. This makes pedestrian travel in this area a bit challenging, and the city has been receiving citizen complaints about all of these issues. So Lee Engineering was tasked with taking all of these things into consideration on this project. We have already completed tasks 1 and 2, which included evaluating the existing roadway to determine how it is functioning today and how it might in the future. We looked at potential design concepts to see if safety and traffic flow could be improved compared to what we have today. Now we are on task 3 and are hoping to obtain feedback from you on the design concepts we will show you later in this presentation. And after we go through all the public feedback, we will be assisting the city in selecting a preferred design concept to construct. The study area includes 3 signalized intersections as shown here. The daily traffic volumes on the area roadways range from 5,000 to 11,000 vehicles per day. The posted speed limit varies by roadway. Embark bus routes 7, 8, and 38 travel through this area with stops shown on this figure. There are also several businesses in this area which constrain the right-of-way available for roadway improvements. This graphic depicts the existing roadway network and the number of lanes along each roadway segment and at each intersection. We've overlaid the existing travel routes so you can see all of the traffic maneuvers out there today. Starting with the eastbound approach, all movements are served. Drivers wanting to turn left onto Penn are restricted from turning left at Penn and must make a left at Virginia. Northbound drivers on Penn wanting to continue north have 2 options. They can travel directly through the signal at 10th and then continue through the signal at the crossover, or they can make a right onto 10th and then an immediate left at Virginia. Moving to northbound approach of Virginia, all movements are served. Continuing to the westbound 10th Street, this shows the available traffic movements. And then on the southbound approach, drivers on Penn wanting to go south onto Virginia have 2 options. They can travel through the crossover signal and then the signal at 10th and Virginia, or they can make a left onto 10th and then an immediate right onto Virginia. There is a significant amount of pedestrian and bicycle activity in this area, and during our site visit, we noticed that accessibility improvements are needed, such as new pedestrian push buttons, new crosswalk striping, and new wheelchair ramps on some corners. We use this count data to perform an operational analysis of the signalized intersections. Results of the analysis were reported in terms of seconds of delay per vehicle and the corresponding level of service. This graphic gives you a sense of what each level of service A through F looks and feels like. So level of service A is considered the best because it represents very low vehicle delays and essentially free flow conditions. Level of service D is what you would experience in most areas of the city during the peak hours. There may be some congestion and delay, but the intersection is still functioning well. And level service F is considered the worst and represents significant delays and heavy congestion. Our analysis showed that traffic progression through the study area was very good overall, and conditions during the peak hour are at level of service C or better conditions. After we perform an operational analysis, we like to go out into the field and verify that our results match actual conditions. So we went out there on a weekday morning and evening during the peak hours and confirmed the level of service C results. There was only slight queuing during the morning commute, mainly in the eastbound direction. In the afternoon, there was slightly more queuing, particularly in the westbound direction, but all vehicles were able to make it through the intersections in one cycle. This means that vehicles did not have to sit at a light through more than one red. We obtained collision data for the most recent 5 full years available, which showed there were 75 reported collisions. Out of these, none included a fatality, but 2 of them included at least 1 suspected serious injury. 3 of the collisions involved either pedestrians or bicyclists. We know of many utilities in the study area that are located within right-of-way. This figure shows the existing sewer and water lines, some of which may need to be replaced during construction. There are several OG&E power lines on private utility poles on the north side of 10th Street, which may be affected. There are no known conflicts with O&G utilities at this time. Now I would like to present to you the first design concept we are considering for this area. Concept 1 is an alternative intersection design. We propose to remove the crossover intersection to the north, so all southbound drivers on Penn that want to get to Virginia would have to make a left at 10th Street and then an immediate right. We also propose to remove the traffic signal at Virginia and provide partial access to the north and south. Some of the advantages of Concept 1 are efficient traffic operations. No significant queuing is predicted on any of the approaches. This design meets driver expectations and eliminates 2 of the 3 traffic signals. There would be quick construction and minimal disruption to traffic. This design is adaptable to traffic pattern changes and fits within the city's construction budget. Some of the disadvantages are access would be limited on North Virginia Avenue. Queuing is predicted on Virginia if traffic does not reroute, and I'll discuss that on a later slide. There would be a signal maintenance cost associated with the 1 remaining signal, and it would not significantly reduce the number of conflict points or the potential for severe collisions in the area. When we predicted traffic volumes 10 years into the future, the alternative intersection is expected to operate with similar levels of service as it does today, low to moderate traffic congestion. The green arrows indicate the level of service predicted at each of those intersection approaches. An important piece of this project is making sure we accommodate all modes of travel, including pedestrians, bicyclists, and bus transit users, since there are many of them using this study area as well. Concept 1 can accommodate all users, and it's recommended that 2 of the bus routes be updated and 3 of the bus stops relocated to better accommodate bus users. The pedestrian signal equipment at Penn should be replaced and all crosswalks should be restriped. New sidewalks should also be installed in areas where there is currently no sidewalk. Concept 1 is anticipated to stay within existing right-of-way. Traffic flow would be maintained in both directions during construction, and property access would be maintained. The estimated cost of Concept 1 is $565,615. I also wanted to make sure that everyone understands the travel pattern changes that would occur with this design. Eastbound drivers wanting to travel northbound on Penn must make a left turn at the Penn traffic signal. On Virginia Avenue, all northbound drivers must make a right turn onto Northwest 10th. As I mentioned earlier, we expect that this change would cause some drivers to reroute to other roadways in the area, especially those who are wanting to go to the west and north. And then finally, southbound drivers on Penn wanting to travel onto Virginia must make a left turn onto 10th and then an immediate right onto Virginia. This slide shows the traffic patterns drivers are anticipated to take if they rerouted from Virginia Avenue. Drivers wanting to go north onto Penn or west onto 10th Street would likely use 7th Street over to Penn or northbound on Indiana or Kentucky from Linwood Boulevard. Concept 2 is a peanut roundabout, which is a roundabout that has been geometrically defined by the number and location of legs. This option would not include any traffic signals, and all approaches would be controlled by a yield sign. The advantages are that Concept 2 would significantly reduce the number of conflict points and therefore reduce the probability of serious collisions. It would eliminate all 3 traffic signals, and it gives an opportunity to put in some nice landscaping, particularly in the center island of the Peanut. The estimated construction cost fits within the city's budget. The disadvantages of Concept 2 is that it is not a design that is common yet in Oklahoma City, and drivers and pedestrians may be unfamiliar with the geometry. Significant queuing is predicted on at least one approach based on future conditions, and it may be difficult for trucks to maneuver. When we analyzed the Peanut roundabout for future conditions, the approaches are predicted to operate at levels of service D, E, or F, and that means that significant queuing could occur specifically along the eastbound and westbound approaches on Northwest 10th and the northbound approach on Virginia. Concept 2 can accommodate all users. With this design, we would recommend high visibility crosswalks, splitter island pedestrian refuge areas, like the one shown here, pedestrian activated rapid flashing beacons, and new LED lighting. Concept 2 is expected to stay within existing right-of-way. Traffic flow would be maintained in both directions during construction, and property access would be maintained. The estimated cost of Concept 2 is $1,302,685. Since some of you may have never driven through a roundabout before, I wanted to take some time to illustrate how you would drive through the study area. Starting with the eastbound approach on 10th, all travel routes would be provided with one entering lane. Moving to northbound Penn, 2 lanes enter and exit the roundabout. Same with northbound Virginia with 2 entering lanes. 2 lanes enter the roundabout on westbound 10th Street, as well as 2 lanes on the southbound approach on Penn. Most approaches include a right turn bypass lane, so you wouldn't drive through the roundabout if you were going to make a right turn. To wrap things up, I wanted to remind you that we are currently in the community input phase of this project. We want to hear from you on both of the design concepts, and this will help us in moving forward with a preferred design concept. So please provide any comments because your input is important to us and this process. Once a preferred concept is selected, we will move into the design phase and then on to construction, which we're hoping to start at the end of this year. Thank you for your time and listening to this presentation and providing us with your input on this project. Please click on the form below to leave your comments, or you can email them to Robert Witt at the city.